Hello everyone, in this video let me explain you about the fourth lab exercise, that is K nearest neighbor in basics of machine learning. First of all, K nearest neighbor means you are given a point and you must find which position suits that point. For example, when you are given a group of three flowers, you are given a point and you must predict which flower does that point belong to. So I hope you understand a little bit about that. So let me explain you with a code which you can get easily. Okay. So we are importing the packages like import pandas as PD. You know what you already know. What is pandas used for and what is numpy used for, right? So cbon is used for also, like what is cbon used for, and matplotlib to plot something, right? And from sklearn lot data sets import, from this only the main part starts. These four are the basic, like the basic packages which we have discussed in our previous videos. So these four packages are the new packages for us. So let me explain you more clearly with this. From sklearn.datasets import load underscore iris. Actually, load underscore iris is actually a dataset which is stored in sklearn.datasets. Okay, so from sklearn.datasets we are importing load underscore iris. Okay, I hope you understand. Then the next thing is that from sklearn dot model underscore selection import train underscore test underscore split. So this is actually the basic thing we need to know in machine learning. First, we are going to split the dataset into training dataset and the testing dataset. For that, we are going to use train underscore test underscore split. We hope you understand. So from sklearn.model underscore selection, actually from that package are importing train underscore test underscore split. I hope you understand. Okay. From sklearn.neighbors import k neighbor classifiers. So it is actually a package for finding the k nearest neighbor. Okay. So I hope you understand why this is used and this is used and this is used. So next, from sklearn.metrics import confusion matrix, accuracy score and classification report. These are used to predict that how, like, accuracy score in the sense, how our how our how a training dataset and testing dataset work together from the accuracy score. Accuracy score is actually like the accuracy of the point in which does it belong to. I hope you understand. There are three types of flowers, right? Satosa, like Virginia something, vesicular and virginica. Okay, these are the three types of flower. You are given a point and you must find where does that point belong to. So you must find the accuracy of the point, right? So you are given a point and you must find the value of that point. So um, accuracy score is basically used for finding the accuracy of the point. Okay, it is basically that. And confusion matrix, it describes the relationship between the point and the accuracy. And classification report, let's see further. Okay, about this is actually, like, let me explain you the code further. First, understand what are these packages used for. We are using sklearn.datasets, sklearn.model underscore selection, sklearn.neighbors, and sklearn.metrics. Okay, for loading a dataset, import and for training, testing, and splitting, for k nearest neighbor classifier, and confusion matrix, accuracy score, and classification report. Okay, so next thing is that we have load underscore iris, right, from sklearn datasets. From that we are shifting that dataset into iris, like we are shifting that into a variable name. Okay, I hope you understand. And then we are printing that. So it actually contains this only. Okay, 1 2 3 4. Okay, 4 columns. Okay, like it basically means of sepal length, sepal width, petal length, petal width. Okay, so it basically means that sepal length in centimeter, sepal width in centimeter, petal length in centimeter, petal width in centimeter. That's all. Okay, so it is basically this. Okay, so in this data set we have only this, and we also have some. This is actually data of array of. So in this data set we have also like which category this it belong to also. Yeah, we have that. Okay, I hope I'll explain it further. df is equal to pd dot data pd dot data frame of iris of data. So period data frame of iris of data basically means gaining the only this values. Like I hope you understand. Getting only the values of the data. Numerical values is called data. Like iris of data means getting only the numerical values. Okay. So next is that iris of target names, comma and iris of feature values. Feature values in the sense like sepal width, sepal length, as I told before, and target names. Target name basically means like which category does this belong to, and it is actually not given in this just because it has only array. Okay, it is actually array containing only the numbers of petal width and sepal width, but in this package itself they have given target name and feature values included. Okay, so feature values basically means the topic of this is sepal length, sepal width, petal length, petal width. Okay, so and target values means like they it is actually there is actually extra column in this containing, like let me explain you. See, this is actually the original data set. Okay, species, it contains a species data set. There are only 3 species containing of Certosa, vesicular and virginica. Okay, only these species are there, Certosa, versicolor and virginica. Okay, so one that is called target names. Target names is basically the value of the species. Okay, the value of the species is called target names. I hope you understand. Next, x is equal to df. Df, what is df? We have assigned df as only the values, right? So where is it? Values, that is numerical value. So x is equal to only the numerical values will be printed. See, I hope you understand. I hope you understand. Okay. See, x is equal to df. What is df here? Containing only the data. 5.1, 3.5, 1.4. So it contains only the data. Okay, wow. 5. Okay, 5.1, 3.5, 1.4 and 2.2. 0.2. So next, iris of target. Iris of target means what? Target means actually, as I told before, target underscore name is Certosa, versicolor and virginica. But target means only the numerical values 0, 1 and 2. Okay, I hope you understand. Let me explain you. X is this and Y is 0, 1, 2. Okay, I hope you understand. Certosa means 0 and versicolor means no, like 1 and virginica means 2. Okay, then x underscore train, x underscore test, y underscore train, y underscore test, which means basically we are going to split the data set into training and testing data set. Okay, so first we are like sending that x underscore train, x underscore test, y underscore train, y underscore test is equal to train underscore test underscore split x comma y test underscore size of. Actually we are assigning a size for this, and random state 42, that why we are assigning random state in the sense it remains constant for every time we load the dataset. It remains constant, so only for that random state is used. So I hope you understand. I hope you all clear till this. So the next step is we are actually moving into the content. KNN is equal to k neighbor classifier of n underscore neighbors is equal to 30. So let me explain you this. What is this actually? We have loaded from sklearn dot neighbors input k neighbor classifier, right? So kn is equal to k neighbor classifier of n underscore neighbor is equal to 13. Why we are choosing the number as 13? Okay, I hope everyone has this doubt that why we are choosing the number as 13. We can also choose 1, we can also choose 2, we can also choose 3, but the constant value when you want to get is 13 or 15. Let me explain you why. Okay, when you want to predict a point, when you want to actually predict a point, you must see at least 10 to 12 numbers around it, right? At least we must, like how to say, when you are considering one point and when you are considering only other neighbor point which has size which has the like accuracy, you may be flexible in the output. How to explain you? Let me consider this. See, you're like you have this data set basically, and you identify 0.2 as Certosa. Okay, but this you identified this as Certosa. Okay, then only considering this above and below, as if this is correct and this is correct, like ID numbers, we are considering the unknown point as 9. Okay, that is the ID number 8, and the known points as ID number 7 and 9. Okay, for finding the value of 8, only considering the value of 7 and 9 may be not flexible. I hope you understand. There may be variations. See, there are correct point. If they have already given the data set as correctly as, like, how to say, explain it. Consider the unknown point as 8, okay, the known point as 7 and 9, okay. So if they have given only one point, to predict the output, it may be very difficult to predict the output given only one point. If there are 10 to 12 points to predict the output, it will be easy for us, right? So that is the basic concept behind this. When you are given only one point to find the output, it will be like tough, like not tough in a sense, the values may be flexible, like the values may not be stable. When you are predicting with different points, when you are predicting with comparing it with many points, the value may be very good. I hope you understand. Like for real time example, I hope, like, only depending on one thing may be so flexible, but depending on many other sources, like, it will be like very stable, right? So that makes it one, not only comparing with one or two, it is comparing with 13 different neighbors, okay. I hope you understand. This is the basic concept behind n underscore neighbors is equal to 13, okay. So we are assigning this as knn, okay. So we have identified that we have predicted the values with the 13 different points, and we are fitting that into x underscore train and y underscore train. What is actually x underscore train? Basically x underscore train is this, right? So what is x is basically this, and y is basically this. So we are fitting that, like so knn dot fit basically means, like, the data is already trained and it is ready to predict, okay. So that means knn dot fit of x underscore train and y underscore train, okay. So x underscore new is equal to np dot array of. So we are basically training with two data sets. Let me explain it further. And x underscore new is equal to np dot array of, like, we are given some what to say, some values, okay. So some values, and prediction is equal to knn dot predict of x underscore new. So we are basically given some values, and we must find that which category that this values belong to. I hope you understand. There are basically three categories: Satosa, Vesicle, and Virginica, okay. So we are giving this input, like 5 basically means the sepal length, sepal width, and 1 basically means the petal length, and 0.2 basically means the petal width, okay. So we are basically giving one data set from this number, I think so. Any data set, like anything you can give basically from this also you can give, okay. So we are basically giving from this any data, like nb dot array of prediction is equal to knn dot predict. Knn basically means you have identified, like what I have already explained you very brief about, like very long about knn, like how this is worked, okay. So based on that, we are basically doing knn dot predict of x underscore new. We are given an array, okay, array of elements. So we are predicting that elements. What would this be belong to, okay. Predicted class is equal to iris of target underscore prediction. So let me explain the predicted class. Let me wait a minute. So the predicted class is actually, let me explain it. Predicted class, what is this? Predicted underscore class, right? So predicted underscore class Satosa. Okay, I hope you understand. This is basically the basic concept. You are giving the data input as an input, like you are giving this huge data as an input. Okay, so with this data, you are you are training the data set with this huge data, and you are testing by giving only one value, and if that one value is this, okay, where is that one value is this, and if we are testing the data set, like what does this belong to, like predicted underscore class is equal to iris of target names of prediction is basically means this, okay. What this, I'll explain you more clearly. This is the basic concept. X underscore new is equal to np dot array of some numbers are given. Yeah, I have explained you very brief about, like, what are these numbers, okay. Prediction is equal to knn dot predict of x underscore new. We are predicting the values of this, okay. Knn dot predict, Like KNN is basically the k nearest neighbor comparing with those and predicting the values. So again we are predicting with this comparing with this values, that is this value, this 4 values. Okay, predicted underscore class is equal to iris of target underscore name. Target underscore name means what? We have already discussed about target underscore name, right? So target underscore names of prediction. So any value given, they are it is predicting what does this belong to. Okay, I hope you understand. This is, I have explained you very clearly in this. And y underscore predict is equal to k under predict of x underscore test. X underscore test, what is actually x? Its whole data set is equal to x, right? So they are given y underscore predict is equal to k under predict of, we are testing this for whole data set. Like for the above example, we have tested only for a particular array of elements. Okay, for the next y underscore predict, we are testing it for the whole array of elements. So for whole array of elements, you'll be giving like y underscore predict is equal to x underscore text. The testing dataset is given as input. I hope you understand. The testing dataset itself is given as input. Okay, y underscore predict is equal to knn dot predict of x underscore test. I hope you understand. This is predicting only of array of elements, is predicting the whole arrays. Okay, so see, next step, CM, that is confusion matrix. So I have already explained your confusion matrix and accuracy score and classification report. Let me recall you. Okay, what does x underscore test? As I already told you, x underscore test is actually the training data set of, sorry, y underscore test. This is actually the y underscore test. Okay, so with that test data set, we are going to excuse me, this is actually y underscore train. Okay, we are predicting y underscore test. Sorry, I'm sorry, extremely sorry. This is actually the y data set. Okay, we are testing this data set with this predicted data set. Okay, with the data set we need to predict. Okay, I'll explain this line alone again. So CM is equal to confusion matrix of y underscore test comma y underscore predict. This y underscore predict basically means the whole this data set. Okay, and y underscore test is equal to this data set. We are going to find how does this and this matches, does this and this matches correctly. Obviously this will be 100% just because it belongs to the same column. So we are identifying this and this belong to the same category. Okay, so confusion matrix, accuracy score and classification report. Okay, we are doing this for everything. So the confusion matrix returns the true positive value, and since the accuracy score is like 1.0, that is 100% accuracy, we are getting the only the values to diagonal elements. Okay, so this is actually the confusion matrix, and accuracy score basically means how much accuracy this data set, that y underscore test and y underscore predict basically means. Okay, so this is actually in classification report. This is consists precision, recall, F1 store and support. And as shown above, everything is 100% accuracy for one means, as I told, Satosa, Virginica, and like Satosa, Versicolor and Virginica. Everything is 100% just because both the data sets are same. So since both the data sets are same, it belongs to 100%. And everything, the support value is basically confusion matrix. That's all. It is really very easy lab exercise. So I have made this code really very short to make you so understand. So thank you for watching this video fully. Thank you.